Welcome everyone. My name is Sandy Delgado. I'm a forecaster here at the National Grand Center in the Tropical Analysis branch, forecasting branch. I always forget all the acronyms. Uh, Today we are here. This is a treat for us to have Darin. First, welcome everyone to the Blue Waters Mariners. We're going to talk about the North Atlantic, Caribbean Sea, and Gulf of Mexico wind and wave forecast and warnings. This is being recorded, and later after we're done, it will be sent to you to your email. If you have any questions, please put it in the chat, and we will get to those questions at the end of the presentation. So first, we have Darin Figurskey. He's the operations branch chief from the Ocean Prediction Center. So Darin, when you're ready, go.
Thank you very much, Sandy, and appreciate the introduction, and want to say thanks to everybody who's taken time out of their day, wherever you happen to be with Sandy, Chris Landsea, my counterpart at the National Hurricane Center's Tropical Analysis Forecast Branch, and me today. And I'm Darin Figurskey. I'm the Operations Branch Chief at the Ocean Prediction Center in College Park, Maryland. And I'll do about 20 minutes or so worth of slides, turn it over to Chris, and then we'll have some time for a little bit of question and answer session at the end. For those who are interested in asking questions, we'll try to get to them as we can. Go ahead and maybe put some of those in the chat. We can try to get to those. You might have a couple of moments for some raised hands type of thing, but certainly you put them in the chat or the question part. And so I'm going to go ahead and unmute myself and share my screen. And so, yeah, so I'm going to go ahead and I'll turn my camera on a little bit later, particularly as we get into the Q&A part. So the National Hurricane Center and the Ocean Prediction Center are part of for environmental prediction. And the other centers making up the 9 centers of the National Centers for Environmental Prediction are located here on the screen. Ocean Prediction Center in College Park, Maryland. Again, the National Hurricane Center in Miami, Florida. And you'd see the other centers there, and you can look those up online. Just a couple of examples: Storm Prediction Center, the one that does all the severe weather watches, that's located in Norman, Oklahoma. Space Weather Prediction Center dealing with energy from the sun in Boulder, Colorado. Our Environmental Modeling Center, they're the ones that really do the research and implementation of models, and the people that keep stuff going through our computer system, our IT branch, NCEP Central Operations, and there are others listed here. Our Atlantic forecast area from both centers is here on this screen, and in blue is the area of the Ocean Prediction Center, offshore forecasts in the kind of darker blue and darker green, respective to the Ocean Prediction Center and the Tropical Analysis and Forecast Branch. And then in the lighter shades of each color, getting more into the high seas area. On the Atlantic side, we do offshore forecasts here at the Ocean Prediction Center to about the EEZ, or about 250 miles or so offshore. Our high seas official forecast area goes to 35 west for the authoritative warnings that we issue in the high seas area, but our radio fax charts will go all the way to Europe from 31 northward. On the Pacific side, similarly, the Ocean Prediction Center's area in the blue shades are noted there. The Hurricane Center Tropical Analysis and Forecast Branch, or TAFB, which I'll use from here on out, in the green. In the central and central tropical Pacific, there's information from the Honolulu Forecast Office that does that part. And then we also want to recognize our friends up in Alaska, with their offshore waters located just off of the coast of that large state. And from a radio fax point of view, we'll do charts all the way out to Far Eastern Asia, but the area that we do our high seas forecast for will go out to 160 east. And that's all part of the WMO Met Areas. We are part of Met Areas 4 and 12, Met Area 12 in the East Pacific, Met Area 4 in the Western Atlantic. And those are areas in which around the world Each nation has its responsibility for its forecasts and its warnings in the parts of the world that they cover. And so these nations are the authoritative voice for safety of life at sea and marine forecasts and warnings in their respective med areas. It wasn't too long ago that we still did the area of Med Area 16, but that was transferred over to Peru, now probably about 4 or 5 years ago. So why do we do what we do? Well, I just wanted to show over the North Atlantic and the North Pacific a heat map of extratropical hurricane force lows since 2005. And these are just hurricane force systems. In the Atlantic, on average, every season, there are 45 extratropical hurricane force conditions that occur. In the Pacific, there are 36. And with that, that doesn't include all of the storm force warnings, all of the gale force warnings, freezing spray conditions that we warn for, of which, when you add them all together, could be as much as getting close to 5 figures in terms of the amount of warnings that we at the Ocean Prediction Center issue every year. And so it's a tremendous amount of big systems that occur in both of those basins, a lot of vulnerability for the for vessels out there, a lot of rough conditions, dangerous conditions that we have to be cognizant of. And I get, and I think Chris gets them too, emails from the National Geospatial Intelligence Agency, called the NGA for short, notifying us of major issues out over the Atlantic and the Pacific Ocean. And a lot of them could be cable laying, they could be cleanup operations, they could be space debris, they could be derelict vessels. But some of those actually are distress signals. Some are unfortunately people overboard or a sinking vessel. And just from October 26th to November 1st of this year, there were at least 14 events of those other types of things, the distress signals, the ship sinking, the person overboard, and the like, over either the North Atlantic or the North Pacific in that short time period. They might not all be weather related, but some of those likely are. And it just goes to show why we do what we do with the frequency of bad weather that can occur. And these types of things, again, the vulnerability of vessels out in the open ocean, it's important that we're there for the safety of life at sea. I wanted to show just a couple of examples of vessel avoidance. And this is one thing that we really hope that vessels really do in terms of heeding the warnings and the forecasts that we put out. And this is one from October 18th of 2022. This is in the Northeast Pacific, south of the Gulf of Alaska and west of the Northwest United States. But on October 17th, there was a hurricane force low that was developing and forecast, which actually became hurricane force, I think, on the 18th of October. There were 4 days advanced forecasts of that for the conditions of the hurricane force winds and seas of 40 to 45 feet. And just note, in the time frame that goes across the screen from October 17th, from 1622Z all the way to the right, October the 18th at around 10Z, the amount of avoidance that occurred, particularly along the Great Circle Route from the Northwest US to the Aleutians and west from there, and how that avoidance changed over time as the storm system was gradually moving to the north and northeast. Now, the maps for the vessel locations from the AIS are courtesy of Sea Vision, but it's our really hope that everyone, including yourselves, will look at the forecast, heed those, use that information to make the critical decisions to save vessels, to save cargo, to save yourselves, and you make sure things are done and voyaged safely. At the Ocean Prediction Center, we issue over 150 products each day. Chris is going to talk a little bit more about these, but we have our offshore waters forecast, which are transmitted long line, also over the internet. NAVTEC's high frequency VOBRA forecast that our core partners from the U.S. Coast Guard help to get out, our high seas forecasts that are issued 4 times a day for 48-hour periods each, issued via SafetyNet. And then we also have a suite of graphical products available via things like FTP mail, or via the internet, or via radio fax that you can get on predetermined schedules, or as you want them, for example, through the internet or via FTP mail. We have Atlantic forecasts and products. We also have Pacific forecasts and products, a little bit for the Arctic. And this is an example here of our Atlantic surface analysis, which is a combined product done by the Ocean Prediction Center, the Weather Prediction Center, the National Hurricane Center at TAFB, along with WFO Honolulu when you look over at the Pacific side. But on the Atlantic side, each one of those centers takes a part of its area, and then we clip those areas together. So we have almost like a 2/3 representation of the Northern Hemisphere. I think that's about right for lows, major fronts, hazards associated with them. And many of these products, not all of them, of course, but those are available for broadcast, are noted on the Worldwide Marine Radio Facsimile broadcast schedule. If you do a search of RFAX Marine, you'll be able to find that. And that forecast schedule is relentless, but that's helps to drive our product deadlines. I wanted to note that the Ocean Prediction Center, the NOAA component of the U.S. National Ice Center, is now part of the Ocean Prediction Center, and that's located in Suitland, Maryland. We're in College Park, that's located in Suitland, but it does analyses and some forecasting, particularly decision support services for snow and ice in higher latitudes, and seasonally, certainly as far south as the Great Lakes, and if needed, hopefully it doesn't get that cold around here for that long, but occasionally it does into the Chesapeake Bay. So what we do, in addition to all of those other products I just mentioned, we have our National Digital Forecast Database, in which we have graphical forecasts, gridded forecasts of winds, waves, visibility, and hazards going out 7 days, usually for about 3-hour periods, for about the first 72 hours or so, and then 6-hour periods from there. And from there, you can download things like I see on the right, the winds, the seas, very specific forecasts of winds and waves, and again, hazards in those time frames, again, going out to 7 days. The Tropical Analysis and Forecast Branch in Honolulu, you can see on the south, they cover a large part of the tropical Atlantic. And over time, we at the Ocean Prediction Center want to extend our footprint from near the EEZ of the United States out across the North Atlantic and the North Pacific Ocean. We're working on that now. How we do what we do? Well, everything starts with the foundation of observations. And it starts from things like satellite imagery. Satellite imagery is very important to what we do. On the left is a visible satellite image out from January of 2020. This is in the North Pacific, but you can see a low pressure system over the area of the North Pacific south of the Aleutians, other lows in the Gulf of Alaska and southeast off the west coast of the United States. This main system has a front that drapes to the southeast and then to the southwest across Hawaii. And it's through satellite imagery that we are helped to understand where the lows are, how strong they are, where the fronts are, and where they're moving, and so on. We also have altimeter imagery that we look at from satellite. What's an altimeter imagery? Well, it's a satellite that helps us to understand what the wave heights are. And in this case, on the right side, this is an image from the Northeast Atlantic, but this one is an image taken, I think it's from October of 2020, October 27th, and this shows image of 59-foot seas in the calm ahead where there are real strong winds associated with this hurricane force low at the time. Scatterometry. This is other satellite data that we get from satellite. And the hotter the colors, the stronger the winds. But satellite has the capability to provide for us wind speed and direction. Again, the hotter the colors, the stronger the wind. And these bright colors off of the Carolina and Mid-Atlantic coast show hurricane force winds with storm conditions in the browner colors and widespread gales associated with the yellows. This is from January 4th of 2018. So this really helps with our situational awareness and helps to enhance our forecasting, understand where things are. I'll talk about observations in a minute, but from all of those satellite observations, vessel observations, buoy observations, we start to take a look at which model is doing the best. Which one has been handling the forecast situation well over the last few days? Which one, for maybe the situation we're in, is looks like it's incorporating things appropriately. And so we'll look at things like the Weather Service's Global Forecast System, in this image in yellow, or the European Center's forecast, in this image in orange. This is both from 10Z on November the 10th, just a little less than a month ago. And in this case, shows real strong low pressure. I think this might have been Nicole actually moving inland over Florida at the time. High pressure located to the north and east, and low pressure over the United States. And you can see in this case, really good coordination with the model guidance in terms of the location of features and by and large the strength of the features. And so we'll look at the model guidance to help us make our forecasts. And I mentioned observations, we definitely look at those. And while this is a dated image from July of 2015, we really value the observations that we get from ships. And in this case, this is out over the north central Atlantic. Up to the northwest is Nova Scotia. This is a vessel observation of 65 knots from the northwest in vicinity of this really tight circle and kind of comma feature associated with a low pressure system and a front kind of off to the east and draping off to the south and southeast. And in this case, we had storm force conditions in the forecast. Based on the observation we got, we quickly updated to a hurricane force wind warning to help vessels in the area understand the stronger nature of the system than what we forecast, and hopefully even a short fuse basis to make some critical decisions. Sometimes the model's as good as they've gotten. They're not perfect. And this is an example of the model guidance around the same time as that observation, showing low pressure off to the south and southwest of where that observation was taken. And if you would ideally go counterclockwise in the northern hemisphere around the low, where that observation was, the model was thinking it was going to be a southeast flow, and not certainly as strong, probably about maybe gale force, maybe in that 30 to 35 knot range, but it was actually northwest flow with the low just a little bit to the northeast right here. And so the model wasn't, quite exact. It's not too bad, but thinking globally where things are, but still with enough error that didn't have it right. We need to update our forecast based on what we saw from the observation and based on what the model was showing. And this map really goes to show again why observations are so important. The reds are the areas where there really aren't too many observations at all. Per grid point, maybe 0, maybe up to 5 per month per grid point on average. And you get into the blues, you might get 26 to 250 observations per grid point or per grid per month. But that still can be as few as 1 per each grid per month. And so the observations that you take get to forecasters. They're really important for forecasters. They're looked at by forecasters. They make a big difference in our forecast process, and we thank you for doing them. Another example of why observations are so important, this is scatterometer imagery from our computer system that we use to make our forecasts. And since they're polar orbiters, they do swaths. And sometimes in the middle of a major system, like here, as you get off the southeast coast of the United States, in the vicinity of Bermuda and just west, there's a big gap in the swath of that satellite strip. And we really, without observations, we won't be able to ascertain really what's going on in there, aside from inferring what models are showing us. One of the primary tasks that we've really increased on over the years and continue to do that with our core partners is decision support services. And we at the Ocean Prediction Center, and Chris will talk about a little bit his presentation from TAFB, support the Coast Guard, one of our core partners with decision support services. And as needed, we'll help out others, maybe like FEMA or other people in NOAA, like our Office of Response and Restoration, who might need to do such things as helping an agency with oil salvaging and the like. And so we'll provide decision support services. Here's an example on the right where led by OR&R with supporting also the Coast Guard and other NOAA agencies. Crews were out there trying to get almost 500,000 gallons of oil from a shipwreck from World War II that was off the coast of Long Island and was every once in a while putting some oil debris on the beaches. They wanted to get the oil from that, and they were able to do that. Unfortunately, there are some times where we actually have to help the Coast Guard with things like rescue and recovery. Hopefully we don't have too much of the latter and even not too much of the former, but still we're there to help the Coast Guard and its assets and people who may be in distress know what the winds and seas might be, so that if a operation needs to take place, crew members, divers, aircraft can do those things safely. We're also working on the electronic chart and display information system and working on trying to incorporate more and more of our images into that, and also helping to develop the standards for meteorological data and forecasts and warnings globally. We're helping to work with nations around the world. And I think there's a meeting going on right now in Monaco where they're talking about requirements, or they're talking about standards of that. And we're heavily involved in that. And we think that's a great benefit to incorporate our data into a system where you can also look at navigation items and other data items from your vessel, all incorporated into one thing. So you have a really good suite of information at your fingertips that's easy to incorporate weather into. The future of high seas forecast, right now we type our high seas forecast largely by hand, and sometimes those things can be quite long, particularly this time of year when we might have 10 warnings or more in the North Atlantic and the North Pacific each, along with the information that we incorporate into those forecasts from Honolulu as well as from TAFB and send them out as all one big package. They can be as much as 15,000 characters or more, hard to read, hard to interpret, sometimes hard to plot. And what we're working on right now as a group is looking at polygons where we can graphically show more about where the stronger winds are, where the stronger seas might be, maybe write them more like you saw with the NGA type of bulletin just a few slides ago, hopefully making it easier for that critical decision maker out over the open ocean to understand where the hazards are, where they're going, how to interpret that kind of thing. And one of the reasons why is because the way we write them right now is based on low pressure systems by and large. So whatever the situation is with a low, we tend to incorporate the weather associated with each low. And with the higher resolution of satellite imagery, with the higher resolution of model imagery, we could see upwards of 7, 8, 9 lows, all associated with one big low pressure system that's out in a part of a basin. And in this case, I'm going back to show, this is November 6th of 2022. I believe this is the becoming extratropical Martin. There was a tropical system to the western part of the Atlantic a few days before. And with that bigger system, there was a low here, a low to the southeast of Greenland, another low off the southwest coast of Greenland, another low off the east coast of Greenland, and a couple of other lows associated with that. To describe each of the weather features and the winds associated with each low makes for a very long forecast product. On the other hand, though, if we focused on the areas in a polygon sense where the brighter colors are, gale force conditions in the yellow, or a swath of gales plus some storm force conditions in the tight gradient off the southern coast of Greenland, I think that representation would be much easier for the 21st century mariner, and we're definitely looking toward that. I just wanted to note, and I just have a slide or two left, with the incorporation of the NOAA component, the U.S. National Ice Center into the Ocean Prediction Center. We are again doing forecasting and decision support at high latitudes, and we're working closely with core partners. For example, this year in the Great Lakes, we worked with the Coast Guard on ice freeze up for some activities out there. We also worked with the National Park Service as they were trying to look at wolf populations in Isle Royale and around Isle Royale National Park, just off the coast of the Northwest Upper Peninsula of Michigan. And there was some marine activities going on with that. So the Ice Center was heavily involved there. And just to note, our social media, Facebook information is there with the website, our Twitter handle over there. And just note again, the monthly average of North Atlantic hurricane force wind events is kind of in this bell curve here. And as we're getting through November, now into early December and January into February, just know we're getting into the peak of the extratropical hurricane force season in the North Atlantic. And so with that, thank you very much for your time and attention. I'll stop my presentation here and go on mute and turn it over to Chris.
Thanks, Darin. Before we go to Chris, I got a few questions here that may be pertinent before, or just are we going to just yes, let's go quickly. It says, what does the OPC wind wave forecast change from feet to meters from the 24 to 48 hours forecast?
Oh, so a very good question. I appreciate that. And I'll put my screen on as I'm answering that, or my camera. So the 24-hour forecast right now, based on our workflows, that's kind of focused over near the EEZs, again, just off the east and west coast of the US, whereas our 48-hour and 72 and 96-hour wind wave charts go out the extent of the basin. Because of our workflows right now, we're forced to do the 24-hour that way, and we do it in feet, particularly because one of our core partners, the US Navy, really wants that information that close to shore in feet. that's something that in customer feedback that they've really wanted. I will note that expanding that is high on our list of things that we want to do. In addition to the full basin grids, and also we have a transition in computer forecasting platforms that we're in the midst of right now. Those two things are a little bit the highest priority, but really close up to the list is expanding those 24-hour suite of products. And when we can do that, we would expand that to extend like the 48, 72, and 96 and have those be in meters. But that's a little ways off. There'll be a public information statement out when we can do that.
Excellent. We will leave the rest of the questions for later, but I thought that was pertinent to ask now. Okay, now let's change gears and let's go to Chris Landsea. Dr. Landsea, he's the Tropical Analysis and Forecast Branch Chief here at the National Hurricane Center. So Chris, when you're ready.
All right, great. Can you hear me?
Yes.
And you can see my screen?
Correct.
Great. Okay, so thanks for the opportunity to speak about some of the products and services we provide here at the National Hurricane Center in our Tropical Analysis and Forecast Branch. So at the bottom right, you can see our different logos. Yes, TAFB is part of the National Hurricane Center. We're actually the largest component of the National Hurricane Center with our 18 marine forecasters. And so like Darin and his group at the Ocean Prediction Center at College Park, Maryland, we provide wind and wave forecasts and issue warnings over the tropical North Atlantic, Gulf of Mexico, and Caribbean Sea. You might think there's no way with a guy whose name is Chris Landsea that is his real name, given that I do marine forecasting, but it is. Sometimes your name works out with your line of profession there. So, but I'm happy to help out and provide a little overview about what we do here, even with a real weird name like that. So Darin talked quite a bit about some of the observations that are available. I did want to talk a little bit about the hazards. And this time of year, we don't have to worry about tropical storms or hurricanes as much, even if our colleagues across the hall did a special tropical weather outlook for a gale that's in the middle of the Atlantic right now. But these colors indicate where you can get gale or even storm force wind events. And they are tied to winter conditions, so extratropical cyclones or cold fronts, as well as the topography. So the areas that we most frequently see gale warnings during the winter in the Caribbean, Gulf, and the Atlantic. First, in the Gulf of Mexico, you get a strong cold front. So into the area near Tampico, you get funneling of those northwest winds. Very common to have gales there, but they can occur anywhere in the Gulf of Mexico, as shown in the yellow. Quite common to have gales just off of northeast Florida, north of the Bahamas. But again, you can get them anywhere throughout the tropical North Atlantic. We see very common conditions for gales just north of Colombia, near the ABC Islands as well. And then the passage between Haiti and Cuba, as well as the northwestern Caribbean. So again, these are linked to winter patterns, extratropical cyclones, but also interacting with the topography of that often helps to funnel the winds over the open ocean. I did get a question beforehand from Joan Conover from Seven Seas Cruising Association. What is the continued La Nina likely to mean for cruisers in the Caribbean and the Gulf and the tropical Atlantic? Well, the best we can know is that south of the Bermuda High, which is going to be around 30 to 35 north most of the winter, that we may see enhanced trade winds. So, on average, it might be 1 or 2 knots stronger, anywhere from 10 north up to 30 north, if the climate forecast system models correct. So that would be the expectation for this winter from the Weather Service's climate model. Darin talked about the importance of ship observations, and I did want to give a shout out to the Voluntary Observing Ship Program, VOS. It's a global program, and the Weather Service runs this for the United States. And it's real important that we get your measurements. So if you're seeing winds and waves, but you're not sending them to us. We have no idea what you're experiencing. And the more that we get information, ground truth from the mariners, the better forecast we can provide. So I would implore you for your company to join the VOS program if you're not already on there. And there are being efforts made to make this more automated instead of a shipmate having to type it in and send it out. So that's the VOS program. Also did want to say a little bit about how you get weather forecasts over the open ocean. It really depends on the technology on board. So close to home, you can have NOAA weather radio. You would have your Wi-Fi on your phone. But further out over the open ocean, really depends. Do you have radio fax to look at graphics? Do you have NavText to see text products? Certainly, I would hope everyone has Inmarsat for satellite transmission of both the high seas and the warnings. Iridium is coming on board, and so they're going to be an option in the near future for satellite transmission as well. But more and more folks are getting internet available directly, and so we're realizing that in the Weather Service, and we're moving toward that that eventuality of high-speed redundant internet available at lower cost. Not here yet, but getting close. Darin also mentioned the unified surface analysis. This is our weather map that we draw every 6 hours, and it's a combined effort between the Weather Prediction Center, the Ocean Prediction Center, and the high latitudes of the Atlantic and the Pacific. Honolulu Forecast Office in the Pacific, and we do the tropical Atlantic and tropical Pacific. So I like showing an example or two. So this is the weather map for today from the 12Z map, and it was drawn today by Cassie Mora, and she shows this gale that's over the tropical North Atlantic, gale force winds on the north side. It's not a tropical cyclone yet, but it might turn into one of these rare off-season ones. And you do see where we have frontal boundaries depicted as well, with a cold front northeast of the Bahamas and a warm front over the southeast US. So these weather maps really form the foundation of our forecasting system. Before you can make a prediction, you need to know what's going on now. What is forcing the winds, rainfall, or the waves? We also have one major discussion product. This is a free form one where we have a paragraph to talk about what's going on now, and then a paragraph to talk about the forecast. And we have one section for the Caribbean, one for the Atlantic, one for the Gulf. And so I think it's worth showing that and seeing what's in the discussion today here. So this was written just a few minutes ago, also by Cassie. So any gales that are highlighted, so you can see we're talking about that Atlantic. It's actually a storm warning because it's anticipated to reach 50 knots over the open ocean. Pretty rare event. Gulf of Mexico information, Caribbean Sea, and the Atlantic. And so this is where you get a chance to peer into the mind of the forecaster to get the latest information about what's going on. All of our other products stem from our gridded database of winds and waves and warnings, and those help us produce the graphics, both radio fax, as Darin mentioned, as well as web-based, and our text forecast products, the high seas and offshore zones. And so we're really trying to spend as much time on the oceanography and meteorology, get it into our gridded database, and then all of our other products fall out from there. So the high seas is the one that's mandated by the Global Marine Distress and Safety System. And this is the one that really focuses on the big stuff. And so for us, at least 8-foot seas and strong breeze or greater, so 25 knots. It is issued 4 times a day, once for the Atlantic, once for the Pacific. We have an offshore zones where we go into more detail. For each of these polygons, it's a 5-day forecast, and it does include any warnings, either hurricane warnings during the June to November season or non-tropical warnings this time of year. And it's excited to point out that we expanded that substantially back on April 5th, in particular to the cruiser community that goes from the Lesser Antilles to Bermuda. We filled in that gap in services with additional zones to help meet your needs as you're transiting northbound in the summer and southbound in the winter time period. Let's take a look and see what the forecast is today. This is the GUI that we use, that we provide for users. So let's say you're in Bermuda and you're heading southbound. Well, you can just click, just mouse over that Atlantic zone number 66 and see that conditions, not too bad now, but getting up to strong breeze conditions by Tuesday night, and seas 12 to 14 feet. It would not be a good time to make a crossing in a fairly small vessel. You can also see same thing pop up for each of these polygons, has the winds, has the seas, and has any warnings that are in place. You can see the gale conditions possible and a storm warning for that northeasternmost polygon there, which is well southeast of Bermuda. So it's exciting that we are able to expand those capabilities there. We also do provide NavTex. So I have a quick question. I'm going to ask a couple little polls here as I go along. If you could put into the chat box either a yes or no, do you still use NavTex, which is a text-based product? The Coast Guard has a medium-range transmitter, and it sends out information that combines our forecasts as well as the local weather forecast office. So either a yes or no, yes, I still use NavTex. I have a medium-range receiver on my vessel, or no, I don't use that anymore. I'd be curious. So Sandy, if you could take a quick tally of that in a couple minutes.
So far, we have 1 yes and 3 no's.
3 no's. All right. Next product is the Vobra. So this is similar to the NOAA weather radio, but it's on a frequency that can be received hundreds of miles offshore, and where we take a subset of our offshore zones to provide that. Radio fax. And so this has been the mainstay for marine prediction and providing those forecasts to mariners over the open ocean. We're very fortunate for the colleagues at the U.S. Coast Guard for maintaining these high frequency transmitters. So I'll go through some of the products, and they are both available as a radio fax product. They're available through FTP mail if folks access our products in that. I know that a lot of cruisers use FTP mail, as well as our website. And so the first one would be the Surface Progs. That is a forecast. Day 1, day 2, day 3. We issue these twice a day. And you can see an example here, the frontal boundary extending from a low near Texas eastward across the Bahamas. And let's just take a quick look at what the forecast is today. This was issued earlier today by Scott Stripling, one of our lead forecasters, and pretty busy conditions. So he's showing 3 days from now, so that would be Thursday morning at 12Z, possible gale with that low center over the central Atlantic. It's about the only game in town, but that's going to be fairly impactful. Also have sea state analysis. That is, what are the conditions of the waves now? And so it shows wave heights in feet. All of our products right now are in feet from the Tropical Analysis and Forecast branch, and also shows the direction of the dominant wave, so you know which way these strongest waves are moving from. So we also provide a prediction of the winds and the waves, and this shows an example. We have day 1, day 2, and day 3 once again, and one product for the Atlantic Basin and one for the Pacific. And let's take a quick look again at what the forecast is. This is still the one from last night, issued by Stephen Conrick. The winds are 10-meter winds. The numbers are the significant wave height in feet. And in this case, pretty windy conditions, well northeast of San Juan, with a possible gale indicated for that area. It looks like he's got wind barbs all the way to 40 knots in this case. So that's an example of our wind wave forecast charts. We also provide wave periodicity and direction. So is it a short period wave, colorized in the kind of the blue colors? Those would be the wind waves, or it could be a long period swell, 15 to 20 second period, showing up in orange or red. Obviously the radio fax version would be black and white. This is issued twice a day, and it's valid for 48 and 72 hours in advance. We also, in the winter time, issue what's called a high wind and seas graphic. Basically, it's a snapshot of any warnings that are in place 48 hours from now. And so this is issued 4 times a day. During the hurricane season, we swap in a graphic called the Tropical Cyclone Danger Graphic to focus on tropical storms and hurricanes. So again, this is both radio fax version as well as the version for the radio fax as well as internet. So that example I showed was pretty boring because it didn't have anything in the Pacific there. So we do also want to let folks know about our marine composite page. And so this is a web-based way to access our grids. You can actually look at our wind and wave grids and any hazards that are out there. So let me walk you through this example. On the right side, the colors are significant wave heights. The wind barbs show surface wind direction and speed. And on the left side is a colorized version of our high seas. So in orange, it shows at least 23 knots, so strong breeze. In blue, it shows at least 8 foot significant wave height. The hatched is a combination. And that red that shows up briefly is gale force conditions. So to me, one could visually look at it. You know, for example, if you're going from Jacksonville down to San Juan and look at what the conditions would be. You can do that in a couple minutes as opposed to try to decipher what can be a pretty complex text product themselves. So let's take a look what's going on now with our marine composite page. So let me zoom in a little more, make it a little more visible. So you, as a user, you select what you want to see. And so let's look at wind barbs. Let's look at wave heights, and you can choose feet or meters here. And then we're going to put on the human-drawn features. So this is the weather map from this morning, again showing that gale that's currently existing. And if we can forward through, this would be for tomorrow morning's conditions. And it shows that as a gale, but developing storm, reaching potentially 50 knots. Forward 2 more time steps. This would be for Wednesday morning. By that point, it may very well be storm conditions with 50 knots. And the colors, again, represent those significant wave heights. Anything at least 8 foot, yellow conditions are 4 meters or 12 feet. And the light red is conditions getting up to about 8 meters or 25 feet. So this is an example of what we provide. We also can just sample our grids, and this shows the strongest wind forecast over the next 5 days. And anything in purple is gale force, and those little blue are storm force, 50 knots or greater. So this is a pretty big event, regardless if it gets named or not by our colleagues across the hall. So I did want to mention briefly our partnership with the U.S. Coast Guard. You may not know, you may be surprised that the U.S. Coast Guard has no forecasters. And so they rely upon the National Weather Service for forecast and product services, such as briefings, and also spot forecasts. Darin mentioned those spot forecasts. It could be for a man overboard, could be for a disabled ship, could be for an airplane that may have crashed, could be for an oil spill, could be for law enforcement where the Coast Guard are chasing the bad guys, could be where they're dealing with migrant vessels trying to reach the United States. Whatever they're needing, we can provide a spot forecast. And last year we provided 80 spot forecasts for 4 different Coast Guard districts in support of their life-saving mission. I did also want to point out the Weather Ready Nation Marine Ambassador Program, which has just started. So if you Google Weather Ready Nation Marine or just WRN Marine, you can join that as a company where basically we're providing services like this briefing. You know, this is how we've advertised to many of you is through the Weather Ready Nation Ambassador Marine Ambassador Program. There's also training available that we make available through the Weather Ready Nation Marine Ambassador as well. So the shout out for that opportunity. We are engaged with social media where, for example, anytime we issue a new warning, we tweet it out right away. So within a minute of us issuing a new warning, it's made available through Twitter. That's one way. We also use Twitter for education as well as providing more detail about any big hazard that's ongoing. I did want to say something that's going to start very soon. We're going to be doing twice a week tropical Atlantic marine weather briefings, where one of our forecasters puts together a PowerPoint and walks through it in about 3 to 5 minutes about what is happening. And I'll just show you an excerpt from what Dylan Flynn did for an example. So the idea is for us to, again, not a new product per se, but a service where we're highlighting the marine weather of interest over the next 5 days. And so we're excited to announce we're going to start issuing that through the NHC YouTube channel starting January 1st, 2023. And here's the YouTube channel. So it's you can just search for National Hurricane Center, TAFB recorded webinars. So we'll be doing that twice a week, not twice a day, twice a week, issued late on Sundays and late on Thursdays. So that's what I wanted to provide for you from the Tropical Analysis and Forecast branch, our 18 men and women that help you all providing forecasts so you can make good decisions and stay safe over the open ocean there. Also, here's our direct phone number. If you ever have any questions about our products or services, feel free to give us a call at 305-229-4424. And there's our website for all of our products. Thank you very much. Do you have any questions for the National Hurricane Center?
Excellent. Thank you, Chris. Yes, we have a lot of questions. I will start reading them, and you guys jump in depending on where you think that your expertise fits better. So we have a question. The prediction models for 2022 hurricane season predicted a much higher than average storm season. However, the actual named storms were a lot less in 2022. Is there a small set of reasons, components that cause a divergence from the models?
Yeah, the forecast was for busier than actually occurred. It was a near average season, and the outlook was had the highest likelihood for active. It's a bit of a mystery. It was mainly the early part of the season. August and early September in particular were very quiet, and that was a surprise. We had a La Nina in place. We still have this long-term variability associated with the Atlantic multi-decadal mode that was supposedly conducive for hurricanes. But yeah, instead of it being a very active season, it was near normal. But that happens sometimes. So the forecasts are not perfect, and that's one reason we do a probabilistic forecast for the seasonal outlook and a range of numbers as opposed to a single exact value.
Okay. Next question. How can we send a condition report?
So if you're looking at,
go ahead, Darin.
All right, I'll take it. So when you're thinking about a condition report, I'm going to equate that right now to an observation. And the way to do that would be through the voluntary observing ship scheme and being involved in that. If you have, because that way you can be part of the entire group and easily, go get into the process of taking your observations and sending them in. If, however, you're not part of the voluntary observing ship scheme, and you're out there in the open ocean and you need to send somebody, let's say, for example, a hurricane force wind report or a major wave report. If you have contact information for the Coast Guard, somebody like that who can relay that to us or get that would probably be the way to go. Chris, you have anything you want to add there?
No, to me, that's the best way. We would love for folks to join the VOS program And so I would suggest checking out their website for more information about that.
Excellent. So next question. How do we feel about products like Windy, and are you looking at having dynamic modeling products available in the future?
I'll start and then let Chris kind of chime in. So when it comes to Windy, I mean, things like that, those types of applications, they serve a purpose in that, we as a government organization, we're the authoritative voice for watches, warnings, general forecasts for mariners, for people on land, for aviators, and all sorts of different groups. But it's difficult for us, it's not in our purview to be able to provide specialized forecasts. So as an example, through those applications, you might be able to get a forecast specific to your route or tailored to your particular type of vessel or cargo, which is something that we can't do. Note that some of those types of applications, they provide for, I'll call it repackaged model data. It takes a computer models, puts it in a graphical format that, again, is pleasing to see and is what you'd like to see. But know that with our forecasts, you get somebody who's looking at 24 hours, 7 days a week, the human over the loop, if you will, to be able to make adaptive forecasts of that information based on a whole suite of model information, observations, satellite data, and the like. So what I'd encourage people to do is ensure that you use the whole suite of weather information at your disposal. If, for example, you're using some of those applications, certainly, continue to use those if you find those to your benefit, but make sure that you look at the information from the Ocean Prediction Center or TAFB or WFO Honolulu, or for wherever you're coming from or going to, so that you have the whole picture at your disposal and know where the watches, the warnings are going to be, where we are thinking about things that are going to take place at, because again, we are the authoritative voice for the watches and warnings, and again, like they were the 24/7, and we're adapting those forecasts based on everything that we see.
Yeah, I would also point out that Windy, while it's great graphics, it's a single model. And so you're not getting our value-added forecast information where we're blending models together. And in particular, during the hurricane season, both TAFB and the Ocean Prediction Center, we're using the official hurricane forecast, putting that vortex into our grids and our predictions. And so we have a consistent set of forecasts that match what the hurricane specialist unit is doing. You're using a single model, you're not getting the best available. And so that's why we would encourage folks to access our gridded information and supplement what you may be looking at with windy.com, for example.
Excellent. Darin, someone complimented your lanyard, says go blue. Chris, you're not promoting anyone, so you're behind the ball here. You have anything there from Colorado State? Oh, there you go. Let me see. There you go. There you go.
Actually, I have a question for the group, for folks who are still on. How many folks use RadioFax? Either use it as a primary method for getting forecast information or use it as a backup? So say yes if you use it as a primary or a backup. Say no if you never use RadioFax anymore.
Okay. Let's go to the next question. It says for OPC, how much can the computer formatter help producing your high seas forecast? Sorry if I missed that part of the briefing.
No, that's fine. We're really looking forward to utilizing a formatter for our high seas forecast. Right now, really the whole process of typing it in a busy weather situation like we're getting into now. If you remember the bell curve, we're getting into the really, really active time of year. It can take an hour and a half to type in all that information. And so we're busy in this whole process trying to get a surface analysis correct, know where the hazards are going to be, collaborate that with our neighbors, including Chris's office at TAFB, get that map out, Also make sure then that we have the high seas forecast correct, looking at the observation, looking at the satellite data. It's very, very labor intensive and takes a while to get done. If we had a formatter in place, particularly that can really incorporate all of the different types of storm systems that we get, and really not focus on each individual low so much outside of tropical, because that's very important to make sure that we have the focus on the system in that regard. But for all the low pressure systems that are moving across the North Atlantic and the North Pacific generally, focusing more on where the strong winds and the seas are going to be, as opposed to each individual little low, some of which could be strong, but many of which are still important, but much, much weaker and transient. Some can form and die very quickly along fronts, especially stationary fronts that are out there. So it makes it difficult and busy. And I think that from the standpoint of the 21st century mariner, instead of reading something that's very, very long and tough to figure out, what's going on where during what time, having that graphical representation is going to be pretty important. We realize, I think, that we need to continue to produce the high seas. I mean, it's required by national, by international mandate and international treaties. And it's a way that we can be sure that people, if nothing else, if you don't have any way to get graphical information or whatever, you can at least get that. And so that's very important to get out there. But I think we need to do it in a different format, a simpler format, a way that your critical decision makers like yourselves out over the open ocean can use it better, use it more efficiently.
Excellent. Chris, I got a question I just saw it. For TAFB, how do you verify accuracy on your marine forecast for winds and waves?
Right. So one of the best ways to verify marine forecasts are with buoys. The moored buoys at the National Data Buoy Center maintain for the National Weather Service are incredible because they have continuous wave information of wave direction and wave height, as well as surface wind speeds. And so internally, we verify our forecasts through those. Over the open ocean, occasionally we'll have ships that we are able to use to verify our forecasts, but we only get about 5% of all the ships that are out there are sending us their observations. So most of the time, there's ships that are transiting the Caribbean or the Gulf or the Atlantic, and we don't know what they're seeing. So that would help us out to have more verification there. Lastly, over the open ocean, there's a couple of radars in space that help us with verification of what's going on. For winds, there's what's called a scatterometer, and the US doesn't have any scatterometers right now, but the European Space Agency operates two, and they're going to be launching a third soon. And so that gives us great knowledge of the winds over the open ocean. Darin showed some great examples of those. And there's also altimeters, which is another radar in space that measure wave heights, and they're accurate to the nearest foot. So for us, the combination of primarily satellite-based, so the altimeters and the scatterometer, as well as the moored buoys that NOAA maintains, those are great for us for verification.
Yeah, thanks. If I can add to that just a little bit. Most of the buoys that we have, they're relatively close into our offshore waters, and there aren't a whole lot of them. So we're verifying our forecast based on maybe just a few points, and it's automated. But we do have through the government Performance and Results Act, I think I had that right, GIPRA, we have measures that we're measured against for our forecast. And I think the accuracy of our wind forecast need to be about 80% to meet the government-wide goals. For seas, about 83%. And I think both of our centers are doing above that. And so, so we're working hard to make sure we're meeting those GIPRA goals. But out over the open ocean, there isn't a lot out there. And sometimes what we do here at the Ocean Prediction Center, we do a little bit more called subjective verification. We'll take each of those surface analysis that we do every 6 hours and try to compare the hazards that the forecaster places on that with the forecast that we had in advance of that. And so one of our forecasters recently looked at hurricane force lows And really, our accuracy here for the hurricane force lows is on the order of about 90%. There's about 5% that we underdo it, about 5% that we overdo it. We're accurate to about it's kind of to about 90% there. That's just with the hurricane force system. So with that in mind, know that the forecasts that we're issuing from both centers with regard to the hazards, are pretty accurate. It's something you should take heed of if you see them.
Excellent. We are basically at 3 p.m. exactly. We have a few more questions. However, I will make sure that they get answered via email, but we have already reached our end, unless we want to keep going. But I know you guys probably have other stuff to do, so I just don't want to exceed the time that we're allowed for this. So thank you so much, our speakers and also the participants that have been here throughout this presentation. And like I said, this will be sent to you on your email that you provided. So thank you so much for being here. And once again, thank you, Chris and Darin. Thank you so much for your time.
Yeah, thank you very much.
Right, and Sandy, just a reminder, we got a Pacific flavored talk tomorrow, also at 2 o'clock.
Correct. We have a presentation tomorrow and at the same time. And like Chris said, I have the information somewhere near here. I'm very new to moderating, so sorry for that. So tomorrow we have another presentation, Northeast Pacific, wind and wave forecast and warnings from 2 to 3 p.m. So if you haven't registered, please do so you can also participate in that one. Thank you so much.